Obey me, computer. All right. Okay, cool. So what are we talking about here? So these branched alkyl substituents. We learned how to name sort of the simplest substituents in our homework that we did. But what if we get a substituent that has a branch point in it, right? So if I look at this molecule here and I apply our nomenclature rules, I'm going to find that longest continuous set of carbons, that parent chain. So in this case, my parent chain is this long set of carbons here. All right. Which means that this whole thing would be considered a substituent. So how do I name that substituent there, right? How do I name these substituents that have branch points in them? They're not just straight chains, but we have a branch point here. All right, so we have two different ways that we do it. We have what we call the common name. Okay. So there are a few specific branch substituents like this one that we see over and over and over again. So they've just been given a simple name that we use to refer to them by, right? So our most common groups were given a simplified name. All right, so what we're going to see is we're going to be able to refer to this branch substituent here, this little fork that I have at the top, by both what's called a common name, all right, but also what's called an IUPAC name. All right, so the IUPAC is the International Union of Physical and Applied Chemistry, okay? All these rules of nomenclature that you have been learning were established by the IUPAC, I think like in the 70s. Basically, they were like, look, Russia's calling their chemicals something different than the US, different than England. We need to standardize this crap so we know what everybody's talking about in chemistry. So they got together and they established this set of rules that you could use for any organic molecule, right? That's what the IUPAC is our nomenclature rules. Importantly, it's a systematic naming scheme, right? There's a rule set that you follow in order to name it. And the reason why is because it works for all molecules. That's the goal of the IUPAC, is to create this set of rules that you can apply to any molecule that you see in order to name it. All right? So we have a common name, which is for a few of the most common branched alkyl groups we'll see. And then we're going to learn our IUPAC, our systematic naming scheme for naming these branched alkyl groups. So again, this little fork thing, by the end, we'll have both a common name and an IUPAC name that we're going to use. Cool. All right, so our common name, this is what our cheat sheet's for here. These are all the ones that have a common name associated with them. Okay? First of all, let's go to the very top. These ones are the ones that we should know how to do. Right? If we have this 3-carbon group sticking off of our parent chain, what would we name this substituent? A propyl group. Right? So these are the ones that we know how to name, our regular old straight chain alkyl groups. This is a propyl group. If instead I had 4 carbons, it would be a butyl group. If instead I had 5 carbons, pentyl. And if I had 6 carbons, hexyl. Right, so these are the ones that we learned how to do from our homework. All right, our next class are these isoalkyl groups. All right, we're going to call them the isoalkyl groups because you'll see they have this prefix iso in front of them. All right, how do we recognize the isos branched alkyl groups? They always have a fork located at the very end of that substituent. All right, so our iso groups here have a fork at the end of that group. Okay, so if we have a 3-carbon fork here, this would be an isopropyl group. Sure. If we have 4 carbons with the fork at the end, this is an isobutyl group. And I think that you see where I'm going here. If I had 5 carbons total with that fork on the end, what would that be? An isopentyl group. And then lastly, if it's all the way at the end with a total of 6 carbons, that would be an isohexyl group. All right, so these are our iso groups here. We recognize an iso-branched alkyl group because it's got this little fork, these little 3-carbon prong at the end of that substituent. Okay, our next category here are our sec alkyl groups. All right, these are going to all start with this prefix sec. All right, and why are these called sec alkyl groups? Because if we numbered, we would see that in each one of these cases, that parent chain is bound to the second carbon in that substituent chain. All right, so how do we recognize our sec alkyl groups? Our parent chain is bonded to the second carbon. Right, so again, I have my parent chain, and just notice for each of these, it is on the second carbon in that substituent chain. All right, and so again, we're gonna kind of just stick the words, that prefix on the front. So this 4-carbon group right here would be a sec-butyl group. For no good reason though, they don't run it all together. They separate sec and butyl with a dash. All right, so then our next one would be a sec-pentyl group and a sec-hexyl group. All right, for a total of 5 carbons or a total of 6 carbons where that parent chain is bound to that second carbon. All right, and then for our last group here, our tert group, we can see that in this case, the parent chain is always bound at a T. All right, so we have this little T formation here for these groups. These are our tert alkyl groups. So our parent chain bonded to a T. All right, so these are all going to get these tert prefixes. Again, you use the dash for these specific ones. So if we have a total of 1, 2, 3, 4 carbons, this would be a tert butyl group. For a total of 5 carbons, a tert pentyl group. And for a total of 6 carbons, a tert hexyl group. So these are these special branched substituents. What we learned how to do in our homework was name these straight chain substituents. So if we had a propyl group coming off of our parent chain, that means that there were 3 carbons sticking off of that parent chain. Now we're talking about these special alkyl groups that have a branch point in them. All right, and these ones have special common names. So if there's the little fork at the end, these are iso groups, and we refer to the total number of carbons, so isopentyl, for example. If it's the second carbon, we call these sec groups. So for example, 4 carbons would be a sec-butyl. And if we have this little T here, we call these tert groups. So for example, tert-butyl. All right. So then this thing here, my common name for this substituent would be what? Which one is this one? Total number of carbons are 3, right? So these common names refer to the total number of carbons that are in there. So this would be an isopropyl group. So if I wanted to name this molecule, that's the name of that substituent. If I wanted to name this molecule, I'd do all my rules. I found my parent chain. In this case, there are 9 carbons in that parent chain. So what's my parent chain name? Nonane. I'm going to number my parent chain. In this case, I'm going to go this direction so that that iso group is on that smallest possible number. So this would be 4 isopropyl nonane. Okay, so this would be my common name for my branched alkyl substituent. So this would be my common name for that entire molecule. All right. So now we're going to talk about the other type of name, our IUPAC name. And this is going to be the systematic set of rules that we apply. It's going to work for this particular isopropyl group as an example, but importantly, it also works for any type of branched alkyl group that you can think of. That's why it exists, right? All right, so we're going to do the IUPAC of branched alkyl groups. And we're going to take that particular example that we were given above, right? So we're going to look at this isopropyl group here. And I'm only focused on naming my substituent at this point here, right? The group coming off of the parent chain. But what we're going to do is apply the exact same set of rules that we learned about for naming a molecule, but we're going to apply it specifically to this substituent here. So again, we're first going to find what we're going to call our fake parent chain. Parent in parentheses here. Because it's not the real parent chain of the whole molecule, that's over here. But within these 3 carbons, we're going to have to name this thing by, again, finding that longest continuous set of carbons. All right, I'm going to add a little bit more onto here, all right? So leave a little bit of room. Step 2, same as before. Find any, again, what we're going to call now our fake substituents. Okay, these are any groups pointing off that fake parent. Okay, so within this branched alkyl group right here, step 1 is I'm going to find my fake parent chain, my longest continuous set of carbons. So these 2 here is the longest chain that I got. All right, I'm going to do any groups coming off of that main chain. So for example, this one here. Okay, since it's 1 carbon, it would be a methyl group. And we're going to number our parent chain. And this is the one place that we have a big difference between when we're naming our molecule as a whole versus when we're naming these branched alkyl groups, rather when we're numbering these branched alkyl groups. for the parent chain in a molecule, you could always number both directions, right? And then you had to decide which one was correct based on whichever put the lowest possible number in the name, right? When we have these branched alkyl groups, there's a rule of what's always going to be carbon 1. And what's always going to be carbon 1 is the carbon that is bonded to that parent chain. That has to be carbon 1 in our numbering of this branched alkyl group. So there's not like the two directions, put the lowest number in the name. I know that the carbon that's bonded to that parent chain has to be carbon 1 in my numbering. Okay? Which means I need the longest continuous set of carbons with carbon number 1 bonded to the parent chain. And in this case, I mean the real parent chain. No parentheses, not the fake one. Bonded to the actual parent chain of that molecule. That's carbon 1. All right, so when we number, we're going to number with carbon number 1 bonded to the parent. Okay, so then the last step here is to assemble all right, so importantly, both the fake parent and the fake substituent will have that YL ending. Okay, so in this example here, I have a methyl group sticking off of carbon 1. So this would be 1-methyl. And my fake parent chain here is 2 carbons long, so F. But since it's a fake parent chain, it's not an ethane, it's an ethyl group. So 1-methyl ethyl would be the IUPAC name of this branched alkyl substituent here. 1-methyl ethyl. All right, and then for no good reason, we're going to finish this off by putting it in parentheses. All right, these branched alkyl groups are in parentheses after we assemble. Okay, so this molecule here, that branched alkyl group, we could refer to as an isopropyl group, or we could refer to it as a 1-methyl ethyl group. And when we put that into our name, we would do it just like we put any other substituent into our name, with that locant out front, then our substituent name, followed by our parent chain name. So if we did the same thing for this one here, it would be 4, and then in parentheses, that 1-methyl ethyl nonane. All right, let's just do, so what you're going to do as part of your homework is to figure out, we'd put what the common name was, but now you can apply that set of rules and systematically determine what each one of these are, okay? Let's take a second and just do one more example. Everybody do this isopentyl group. We know its common name. Find its IUPAC name for me. All right, so I'm going to find my fake parent chain here because my real parent chain is down here. But within this branched alkyl substituent, I need to identify what my fake parent is. And importantly, I'm going to always start by numbering that first carbon as carbon 1, because the thing attached to my parent chain has to be carbon 1 when I'm finding my longest continuous set of carbons. All right, that's kind of an important thing to keep in mind. So then these are going to be my fake parent chain here, my longest continuous set of carbons. This thing then sticking off of that is my fake substituent, a methyl substituent. Okay, so when I'm putting this together, it's going to be 3 methyl butyl. And then to finish it off, I'm going to parentheses around it. Okay? That caveat about this being carbon 1 is really important to keep in mind. Just one other example to kind of hammer this home, and I'm just going to give this to you real quick to think about. If I took this, for example, I'm going to be really tempted to say that these are my longest continuous set of carbons, right? But this cannot be carbon 2. It's got to be carbon 1, right? This one right here can't be carbon 2 in my fake parent. So my longest continuous set of carbons, keeping in mind that caveat that this is carbon 1, is actually just these two here, meaning that these are 2 methyl groups sticking off of carbon 1. So this molecule right here would be 1,1, or rather the substituent right here would be 1,1-dimethyl ethyl. All right, so keep in mind that that carbon bound to that parent chain must be carbon 1 when you're finding your parent chain, your fake parent. All right, 1,1-dimethyl ethyl. All right, cool. One more caveat about how we're going to put this together. All right, let's take a second and name this molecule here. For the sake of time, we'll just worry about its common name. All right, but take a second and name that for me. Actually, I lied. Get through the first 3 steps. Don't try to put it all together yet, because that's the last little bit of info that we need. But find that parent chain. Find and name your substituents. One of them will be a branched alkyl group. And then number that parent chain. Okay, so I've got my parent chain figured out, these 9 carbons. I've got 2 substituents on there, an ethyl group, and then this branched alkyl group. Which one is this one? It's not an iso. The iso has to have the fork at the end here. What is this one? This is a sec butyl group. It's attached, the parent chain is attached to the second carbon in that substituent. So this is a sec butyl group. Okay, I got my locants down there. I went this direction so that I had the lowest possible number in the name. All right, and then I'm going to put these together. And what was our rule for when we assemble with multiple substituents? We put them in. Cool. And so we're still going to put them in alphabetical order with this very annoying caveat that we ignore the sec out front. All right, so on our nomenclature rules, we're going to go to that last step, that assemble name portion, and we're going to say, add this little caveat that's specific for branched alkyl groups. All right, when we put in alpha order, we're going to ignore that sec and tert. All right, and again, I don't make the rules, but you ignore it when it's sec and tert, but not when it's iso. So for whatever reason, if it's an isopropyl group, you consider that I. If it's a sec butyl group, you ignore the sec out front and just look at butyl. All right, so we're going to ignore sec and tert, but not iso. All right, so when we put our name together for this molecule, we know it's a nonane. We have an ethyl group on carbon 2 and a sec-butyl group on carbon 5. Putting these in alphabetical order, I'm going to look at my butyl. I'm going to ignore the sec compared to the ethyl. So that means this molecule is 5 sec-butyl. To ethyl nonane. All right. Again, we have multiple substituents, an ethyl group and a sec-butyl group. We're going to put them in our name when we assemble in alphabetical order, but we ignore the sec. We're paying only attention to the butyl. So 5 sec-butyl, 2 ethyl nonane. Just rolls off the tongue. Beautiful name for a molecule, right? Cool. Okay, so what we have for the last portion of this lecture